Section 5 of National Geographic Magazine, Volume 2, Numbers 3 to 5. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Irrigation Problem in Montana by H.M. Wilson. Part 1. The development of the irrigation resources of a region under the supervision of the government requires study of the social and political conditions and of the industrial occupations of its inhabitants. The determination of the best plan for the utilization of its waters and agricultural lands is a problem in irrigation engineering. The solution of this problem calls for an intimate knowledge not only of the best methods of construction, but also of the values of its various agricultural products and soils, for a knowledge of its rainfall, evaporation, and steam volumes, and of the duty of water. It further requires such an understanding of the topography of the region as will enable the engineer to determine the area of the catchment basin of each stream, and to intelligently select sites for the construction of canals and storage reservoirs, and to determine from what source of water supply each district may be best irrigated. Experience and practice in various parts of the world have already proven that irrigation enterprises, undertaken on a large scale by private capital, have seldom been remunerative investments, in fact, have frequently been financial failures. This is due to many causes, among which may be mentioned the fact that, though all the irrigable land may be finally settled, and the works made to do their highest duty, taxes must be paid for many years and considerable sums expended annually for maintenance before the entire amount of available water is utilized and interest is realized on the whole expenditure. Most of the successful irrigation enterprises undertaken in the United States owe their prosperity to the ownership and sale of lands under their canals. In order to secure a proper remuneration to the capital which provides the water, and an efficient water service to the farmer who uses it, with justice to both interests, state legislation must fully define the rights and responsibilities of appropriators, the units and methods of measuring the flow of streams, granting the right of way and appointing proper officers to see that the various laws are enforced. That irrigation enterprises will have great and rapid development in Montana in the near future will be readily perceived from the facts shown later on in this article, while I am fully convinced that it is now entering on that period. The histories of both California and Colorado have shown that great mining activity have brought to them a large population who were enabled to gain a livelihood by mining pursuits, while the demand for farm products created by the miners caused these people to turn their attention to agriculture, which is now rapidly surpassing in money value the output of the mines. In California in the 50s, mining was the supreme and only occupation. Today, agriculture is her mainstay. In the early 70s, the same was true of Colorado, and now agriculture is rapidly becoming her most important industry. While Montana is today in the van in mining resources and output, the time for the supremacy of agriculture within her borders has received an increased impetus by her recent accession to statehood. In Montana, the irrigation problem presents some features which are scarcely encountered in any other country. Usually, irrigation is practiced in semi-tropic and desert regions, where though water is scarce, the climate is such that a great variety of agricultural products, usually of the better paying varieties, can be raised, in consequence of which enormous sums may be spent in irrigation works, thus imposing a heavy tax per acre on the land for their construction, and still, such is the productiveness of these regions that the lands will yield fair profits. In Montana, the reverse is the case. Water is generally abundant, though sufficiently inaccessible in the larger streams to require extensive works in order to render it available, while the land, though equally abundant also, will, owing to the climate, admit of the cultivation only of the less profitable crops, mainly hay, grain, and potatoes, in consequence of which The cost of construction of the irrigation works becomes a question of vital moment, since a tax of a few cents per acre one way or the other will render the pursuit of agriculture a success or a failure, and decide the fate of the irrigation enterprises. It is probable that $10 per acre for a water right in perpetuity, or $2 per acre per annum for the use of water, is the maximum charge which the crops will bear. Agricultural and mineral resources. It will be advisable now to take a hasty glance at the state of Montana and see what are her agricultural capabilities and what need exists for irrigation as a factor in their development. According to the report of the State Auditor for 1888, there were in that year 143,700 horses and mules, valued at $4,900,000, 488,500 cattle, valued at $9,060,000, 1,153,000 sheep, valued at $2,165,000, 3,741,000 acres of improved lands, valued inclusive of improvements at $12,300,000, 55,000 town lots, valued with improvements at $14,940,000, and including all kinds of personal and real property, a total assessment for the state of $67,500,000. There were raised in the state during the same year 770,000 bushels of wheat on 26,000 acres, an average yield of about 30 bushels per acre, 3 million bushels of oats on 85,000 acres, an average yield of over 35 bushels per acre, 843,000 bushels of potatoes on 3,700 acres, or 230 bushels per acre, and 6 million pounds of all other vegetables on 450 acres. 235,000 tons of hay were cut, and 7,500 bushels of apples and other fruits were raised, while 4,500,000 pounds of wool were sheared. The gross receipts of the quartz mills were $20,300,000. The value of the product of the reduction furnaces was $15,900,000 in bullion, and the coal mines produced 500,000 bushels of coal. The wool product for the present year, 1889, exceeded in amount that of any other state west of the Missouri River, and its quality was such that it brought a higher price per pound than that of any other western state, the price paid in California ranging from 15 to 17 cents per pound against 20 to 23 cents paid in Montana. The accompanying table will show the relative value of the production of precious metals in the three leading states during 1887, from which it will be seen that Montana led Colorado by $4,200,000 and California by $15,580,000. 1887. Silver. Montana, $15,500,000. Colorado, $15 million. California, $1,500,000. Gold. Montana, $5,230,000. Colorado, $4 million. California, $13 million. Copper. Montana, $8,970,000. Colorado, $400,000. California, $180,000. Lead. Montana, $630,000. Colorado, $6,730,000. California, $70,000. Totals. Montana, $30,330,000. Colorado, $26,130,000. California, $14,750,000. Since 1887, Montana has been rapidly gaining in its lead, especially in the production of copper, and it now leads not only in the total value of the precious metals produced, but also in the values of the silver and copper products separately, and is only surpassed by California in the production of gold. While as shown above, Montana produces large quantities of vegetables and grain, its heavy mining population and vast herds of livestock furnish a home market for all of its present product. In fact, during this year, many hundreds of tons of hay and carloads of grain are being imported from the eastern states to feed the range stock during the coming winter. Topography. The topography of Montana is very different from what is generally supposed by those who are not familiar with it, and this erroneous impression is largely due to the fact that the country is very mountainous in the older inhabited and better known portion of the state, which lies in its southern corner near the Idaho and Wyoming lines. This region was first inhabited by those pioneers of western civilization, the prospector and miner, and in consequence of this and of the wild grandeur of the Yellowstone National Park, the generally preconceived notions of the topography and resources of the state are of forests and streams teeming with game and fish, and rugged mountains occupied by a few isolated mining camps and cattle ranches. On the contrary, there are scattered over various parts of the state many large towns, two of which, Butte and Helena, have each about 20,000 inhabitants, while only one-fourth of the area of the state is over 5,000 feet in altitude, and at least two-thirds of it is below 4,000 feet. The mountainous district of the state, which occupies but 2/5 of the total area, is in the southwestern portion. These mountains are in fact but the last remnants of the great Rockies breaking down from Wyoming and Idaho and terminating in the broad flat plains of the Saskatchewan River on the north and of the Missouri River on the north and east. It is in these great mountain ranges that the Clark's Fork and Snake Rivers, two of the principal branches of the Columbia, after rising in the western and southern portions of the state, join the Columbia on its way to the Pacific Ocean. Among these mountains, in the northern portion of the state, the Saskatchewan River rises and flows thence to the Arctic Ocean, while the Great Missouri and one of its principal branches, the Yellowstone River, rise in these mountains and after flowing northward nearly to the British line, turn and flow eastward and join the Mississippi on its way to the Atlantic. The highest mountains in Montana are in Park, Gallatin, Madison, and Beaver Head counties, in which latter the furthermost branches of the Missouri, the Beaver Head and Big Hole rivers, which form the Jefferson River, have their sources at the summit of the Rocky Mountains, and it was here that those intrepid explorers, Lewis and Clark, first crossed the continental divide in 1805 to the headwaters of one of the branches of the Snake River. In these counties, a few of the highest peaks reach an elevation of 11,000 feet, and from here the main range of the Rockies bears off to the north in a long, continuous and rugged ridge of sandstone and porphyry, with extensive beds of limestone north of the headwaters of the Dearborn River, and gradually falling off in elevation until near the British line the highest peaks are less than 7,000 feet above the sea. From this same actual point in the southwest corner, a main spur or branch of the Rockies, called the Bitterroot Mountains, bears northwesterly and falling away in height, gives out with an elevation of 2,200 feet in northern Missoula County, where the Clark's Fork River leaves the state, cutting across the foot of this range. East of Madison and Jefferson counties, and along the southern border of the state, are numerous short mountain ranges, often 10,000 feet and sometimes 11,000 feet in elevation, which have generally a north and south trend and fall off near the middle of the state to a continuous, broad, and nearly level high prairie, or as it is locally called, benchland, which continues to fall slowly in the same direction. Do not imagine that these great ranges of mountains are wild and uninhabited, for such is not the case. They are merely great mountain masses, and between, among and on top of them, are other minor ranges of mountains, usually having symmetrical and regularly sloping sides, which are separated by broad, level, and very fertile valleys, everywhere inhabited and cultivated by the aid of irrigation, while herds of cattle, horses, and sheep graze on the hillsides. Even among the roughest mountains, a man may travel alone on horseback, sure of finding shelter and food somewhere in the course of a day's journey, as was done by the author during the past summer, when he rode over 2,000 miles in various parts of the state. In the more rugged places, mining camps may be met with when everything else fails. At present, these mountain valleys are the more thickly inhabited portions of the country, both because of the mines and because farming pursuits are more cheaply and conveniently followed, owing to the greater abundance of small and easily controlled streams of water, which render irrigation possible even by the poorest settler. Only in the southern portions of Gallatin and Park counties are the mountains so forbidding as to be uninhabited, and then in limited areas only. One of the remarkable characteristics of the Montana mountains is their great regularity and smoothness of contour. It is probable that ice action during the glacial period may have planed off the irregularities, so characteristic of the elsewhere rugged outline of the Rocky Mountains. Between these symmetrical ranges of mountains lie the broad and fertile valleys before referred to. These are generally valleys of construction, and in some former geologic period were occupied by lakes whose beds have since been drained by the streams, as they cut their way out of the mountains. It is the extensive deposits from the ancient lakes which give to these valleys their fertile soils, while the unusual mildness of their climate is largely due to the fact that they are seldom over 5,000 feet in altitude, and the high mountains surrounding them shelter them from the severe winds which, sweeping over the plains of Dakota, become the much dreaded blizzards. East of the Tongue River and north of the Yellowstone and Missouri rivers, the level benchlands are everywhere below 3,500 feet in elevation, and often below 2,500 feet, and are very dry and devoid of water, though covered by an abundant growth of fine bunch grass. These benchlands are traversed by a few narrow, deep coulees or washes, having bluff banks 50 to 300 feet high, dry during most of the year, though roaring torrents in the early spring months. It is on these benchlands that irrigation will find its greatest field, for here is a comparatively mild climate owing to the low altitude, and here the soil is fertile, warm, and deep. Area and kinds of lands. The total area of Montana is 146,080 square miles, or 93,491,200 acres. Of this vast empire, 31,373,000 acres, or about one-third of the whole, is agricultural land, while of this 18,157,000 acres, or a little less than one-fifth of the entire area, is irrigable land, so classified not only because it will, if provided with water, raise profitable crops, but also because, in my opinion, water can, with proper management, be provided for it. Of the total area of the state, only about 1,200,000 acres, or less than 1/16 of the irrigable area, may be easily cultivated. By this I do not mean that this whole amount is now reclaimed, but that it may, with the means liable to be employed by private parties with limited capital, be readily brought under cultivation by the same methods by which most of the lands in Montana are now irrigated. The amount of land actually under cultivation, according to the assessment of 1888, was 348,070 acres, and this should probably be increased by about one-half, since the farmers doubtless greatly underestimated the amounts of their cultivated lands to the assessor. Perhaps then 500,000 acres under cultivation would be nearer the truth. It is estimated that 3/4 of the remaining 75 million acres not classed above as irrigable, or say 55 million acres, which is nearly 2/3 of the total area of the state, will, with the increased facilities for watering livestock and for domestic use offered by the highest state of irrigation development, become valuable as grazing land, since it is naturally covered with an abundant growth of bunch grass, and only needs better facilities for watering and for the establishment of home farms to cause it to be entirely occupied for grazing purposes. Nearly or quite all of the lands above classified as agricultural and pasture lands are now covered with an abundant growth of bunch grass, occasional patches of sagebrush or prickly pear, and devoid of any timber other than patches of willows and cottonwoods along the streams, or a few isolated clumps of scrub pines and junipers on the highest lands. About 10 million of the remaining 20 million acres are excellent timber lands and are situated on the slopes and sides of the higher mountains, though west of the continental divide the valleys and flat benchlands are sometimes covered with timber. The remaining 10 million acres may be classed as barren and rugged mountain peaks, and some little barren badlands near the southeastern corner of the state, and the broken and rough-cut banks of rivers, coulees, etc. It is in these more rugged mountain regions that the great gold, silver, and copper deposits are found. Climate. The climate of Montana is far more moderate and agreeable than is generally supposed, the spring and fall months in the valleys, which are the principal inhabited and cultivated portions, being delightfully mild and pleasant, with frost generally only at night, though these last till May and begin in early October. The accompanying table shows the dates of the first and last killing frosts at Helena, also the mean monthly temperature at Helena, which place is chosen as a typical station, its altitude being 4,262 feet. From this table, which extends over a period of 10 years, from 1880 to 1889, inclusive, with few interruptions, it appears that the earliest killing frost occurred on September 6, 1881, and the latest killing frost on May 3, 1888. But these were very exceptional frosts, the average dates for the same periods being September 26th and April 26th. The maximum temperature during the same period occurred in July 1886 and was 103 degrees in the shade, while no other year showed a higher temperature than 97 degrees. And the average maximum temperature for the 10 years was 94 degrees. The minimum temperature for the same period was -40 degrees, occurring in February 1887, while the average minimum for 10 years was -29 degrees. Great ranges of temperature are sometimes experienced, however, especially in local areas in the higher mountain valleys, where unusual frosts and snow flurries have occurred, though rarely, killing potatoes and other tender crops even in July and August. On September 5th of this year, in the upper Madison Valley above 6,500 feet of elevation, a temperature was experienced in the forenoon of 70 degrees, while at about 8 o'clock on the same evening, a snow squall occurred, during which the thermometer must have fallen several degrees below the freezing point. By 9 o'clock on the following morning, all of the snow had disappeared and the temperature had greatly moderated. The summer months in these mountain valleys are always agreeably warm during the daytime, while the nights are cool and pleasant. In the winter, the climate is very cold, though not so uncomfortable as the temperature would indicate, owing to the dryness of the atmosphere and the absence of very high winds in the mountain valleys. The more exposed plains to the north are subject to the frequent and agreeable visits of the famous Chinook winds, which blow from the west, and under whose influence heavy falls of snow disappear in a single day. The following table shows the mean annual rainfall at various Signal Service stations in Montana, and from these it will be seen that during a period of 10 years the maximum rainfall for the entire state has only been 20.33 inches in 1880, while the minimum has occurred during 1886 and was but 12.52 inches. The average precipitation for this period was 15.25 inches. Moreover, from the first table, showing the average monthly precipitation at the Helena station, it will be seen that but 4.48 inches fall during May 15th to August 15th, inclusive, which is the growing season when the crops require moisture. The information regarding evaporation is as yet very meager, but from 4 stations observed in different parts of the state during August, September, and October, it appears that the total average evaporation for the 3 months was 18 inches, and from the best information obtainable, it appears that the total annual evaporation is 36 inches, that is to say, the surface of the water in a lake or reservoir will be lowered by evaporation 3 feet in a year. End of section 5.